Hey everybody, thanks for checking out this video tutorial on 5.3. Today we'll be discussing how to identify a proportional relationship. Okay, chapter 5 is still on ratios and proportions, and our learning target today is I can determine when two ratios are equivalent. And I just noticed I spelled two wrong. TWO, Mr. Gillis. All right, so we're going to identify proportional relationships. What is a proportion? That might be a new word to some of you. Okay, a proportion is an equation, so it's got an equal sign, stating that the values of two ratios are equivalent. All right, in this example, it says 2 to 3 and 4 to 6 are proportional. All right, two ratios. I like to think about this using a little bit easier numbers. And of course, I'll go back to my example of pizza. Love pizza. If I have a pizza and I cut it in half and I eat one out of the two pieces of pizza, that's the same thing. That's the same value as if I were to have a pizza that was the same size and cut it into 4 total pieces, and I eat 2 out of those 4 pieces, right? This is a ratio, 1 out of 2 pieces, and this is a ratio, 2 out of 4 pieces, and this is saying that these two values are equivalent. And you can see that by this model. I eat half of the pizza. And how do you know that? Well, there's a bunch of different ways that we're going to work on today that you can test to see if two ratios are proportionate or not. One way is you can divide. Right? This means this fraction 1 over 2 could also mean 1 divided by 2, right? Which gives us 0.5. Move our decimal 2 spots, 50%. Is 2 divided by 4 the same thing? It is 0.5 or 50%. So that's one way that you can check. We'll also do a couple other methods. All right, so example 1, determine whether ratios form a proportion, just what we did here. Letter A says 6 to 4, so my first number is my numerator, my second number is my denominator, and I'm trying to see, is that equivalent to 8 twelfths? Okay, so when it says tell whether the ratios form a proportion, this is a yes or a no question. Okay, so like I said before, you can use a calculator. I'm going to show you another way right now. The other way you could solve these is you could simplify each ratio. All right, 6 and 4 have a common, what do they have in common? Well, you could divide each of these numbers by 2. If I divided by 2 on top and divided by 2 on bottom, that would give me 3 halves. And now I'm in simplest form, right? They have that common factor of 2, divided each by 2, 3 over 2, or you could also think about this as 1 1/2. Right? 2 goes into 3 one whole time, and there'd be 1 left over. Well, some of you might already be seeing that 8 twelfths, well, that's less than a whole, right? If to be bigger than a whole, my numerator would have to be greater than my denominator. So if I simplified this, if I divided by, 4 on top and bottom, 4 would be a common factor. 8 divided by 4 is 2. 12 divided by 4 is 3. Is 2/3 the same as 3 halves or 1 1/2? And the answer is definitely not. Those two ratios do not form a proportion. No. Okay. Let's try letter B, where it says 10 40ths, so 10 to 40, and 2.5 to 10. Let's try and see if these are proportionate. Well, maybe you want to try getting the same denominator to be able to compare them, right? This denominator is 40, this denominator is 10. Could I make 10 into 40ths? Well, sure, I just have to multiply by 4 on the bottom. And if to keep this ratio equivalent, I'd multiply by 4 on top. Okay, 2.5 times 4. 5 times 4 is 20. Carry my 2. 4 times 2 is 8 plus 2 is 10. And then I need to move my decimal one place in the final answer. So 10.0, which is the same as 10. Well, look at there, 10 40ths and 10 40ths. Are those, do they have the same value? Definitely. Yes, they form a proportion, right? Again, if you wanted to double check that with the calculator, you could. 10 divided by 40 is 0.25, right? 0.25. And 2.5 divided by 10, well, you just have to move your decimal, is also 0.25. Okay, so yes, those definitely form a proportion. Those two ratios have the same value. Okay, so go ahead, excuse me, and pause the video now to try 1, 2, 3, and 4 on your own and see if you can determine if those ratios form a proportion. Okay. 1 to 2 and 5 to 10. 1 to 2, is that the same as 5 to 10? Well, definitely. I could multiply by 5 on top and bottom and get to that. So, yes, definitely. 1 is half of 2 and 5 is half of 10. 4 to 6 and 18 to 24. Kind of looks like it at first. This would simplify to 2/3. 18 to 24 would simplify, if I divided each by, let's see, 6, I'd get 3/4. Ooh, 3/4 and 2/3 are not the same value. Number 3, 4.5 to 3 and 6 to 9. Well, right away, I can see that my denominator is smaller than my numerator. So this is going to be greater than 1. And I know this is less than 1 because my numerator is smaller than my denominator. So definitely not. And then for number 4, you should get yes. Okay. So let me know if you had any questions on 1, 2, 3, and 4, and I'll be happy to help. The next key idea talks about another method that can be quick and easy, and a lot of students like this method. I like this method. It works all the time. I might star this if I were you. This is a great way to check and see if proportions are equal, and that's to use what's called the cross products property. The cross products of a proportion are always equal. So here we had 2/3, and we're saying that's equal to 4/6. If you wanted to check that, okay, multiply the cross product, so your diagonals. So 3 times 4 is 12. Does that equal 6 times 2? 6 times 2 is 12, so yes, it does. Some people or teachers refer to this as the butterfly method. It kind of looks like you're making a butterfly, but multiply diagonally, and the cross products of a proportion are equal. So let's try that using cross products in the next example. Okay. Tell whether the ratios form a proportion. Okay, 6 to 9. Does that equal 12 to 18? All right, let's do our cross products. 6 times 18. Okay, that gives us 108. Does that equal 9 times 12? Well, 9 times 12 is also 108. So yes, those form a proportion. Letter B, 2 to 3, is that equivalent to 4 to 5? Well, 4 times 3 would give me 12. Does that equal 5 times 2, which is 10? And definitely not. It does not form a proportion. So you can kind of see how quick and easy this method can be for testing to see whether two ratios are equivalent or not. All right, go ahead and pause now for 5 and 6 for the on your own. All right, tell whether the proportions or the ratios form a proportion. So I have 6 to 2 and 12 to 1. 6 to 2, does that equal 12 to 1? Well, 2 times 12 is 24, and 6 times 1 is 6, so definitely not. The next one, 8 to 12, does that equal 2/3 over 1? Well, 8 times 1 is 8, and what's 2/3 times 12? 12 over 1 times 2/3. I would simplify first, so divide each by 3 would be 4 and 1. Multiply across would be 8 over 1. So does 8 equal 8? Yes, it definitely does. Okay, so no for number 5, yes for number 6. Let me know if you have questions on either of those two. And then we'll finish with another example and a try it. Very similar, except now we're just looking at a table. Okay, so two quantities are proportional when all of the ratios relating to the quantities are equivalent. Okay, these quantities are said to be in a proportional relationship. So what we need to do is we need to check and see if we do to go from X to Y, are we doing the same thing here for each one of these sets, data sets here in this table. Okay, so let's compare the values of ratios of X to Y. Okay, so I could say one way I could do this is how would I go from X to Y? How could I go from 1/2 to 3? Well, I could multiply by 6, right? 6 times 1/2, or 1/2 of 6 is 3. Do I do that for my next data point? 1 times 6, is that 6? Yes, it is. 3/2 times 6, does that give me 9? 3/2 times 6 over 1. Simplify, divide by 2 would be 1 and 3. Multiply across would be 9 over 1. Yeah, it does. And does 2 times 6 give me 12? Absolutely it does. You can see that here, to go from X to Y, I multiply by 6 on each one of these ratios. So tell whether they're proportional. Yes, they definitely are. Okay. Now, if you wanted to, you could also set up some ratios to check, right? We could say that when X is 1/2, our Y is 3, so we could set up a proportion of 1/2 to 3. Is that equivalent to my next data point, which would be 1 to 6? When X is 1, Y is 6. Well, cross multiply. 1/2 times 6 is 3, and 3 times 1 is 3. So definitely yes, right? So you could keep doing that to check here to make sure that those are proportional. All right, go ahead and pause to try 7 and 8 on your own here, and that will wrap things up for us. All right, looking at number 7, you can kind of just look at this table. I like when they're written horizontally like this because I've got the fraction 1/2. Does that equal 2/4? 1/2, does that equal 2/4? Well, yeah, that's that opening problem that we did, right? They both, if you were to divide, you'd get 50% or 0.5? Does that equal 3 to 6? And does that equal 4 to 8? Yeah, you can see our numerator is half of our denominator. You could test by using the cross products. 1 times 4 is 4, and 2 times 2 is 4, right? So definitely, yes, these are proportional. And for the second problem here, when x is 2, y is 4, does that equal 4 to 2? Well, I can tell you right away, 2 over 4 simplifies to a half, and 4 over 2 simplifies to 2, right? 4 divided by 2 is 2. Is a half the same thing as 2? And the answer is definitely not. Okay. If you do cross products, 4 times 4 is 16. 2 times 2 is 4. 16 does not equal 4. Okay. So there you have it. That wraps up section 3 here, and determining whether two ratios form a proportion. And let me know if you have more questions. Thanks for tuning in today.